For numbers 29 through 35, it says label each linear function as proportional or non-proportional and why. So when we start off at 29 and 30, these are equations. So whenever we have equations, a proportional equation is written in the form y equals mx. So here there's only multiplication occurring. If I have a non-proportional equation, that's written in the form y equals mx plus b. Here you can see that the difference here is that I have an addition sign here. So the difference would be that there would be adding and subtracting occurring for a non-proportional equation. So here at 29, I only have multiplication occurring, so this is proportional. For number 30, I have subtraction occurring here, so this is non-proportional. So going down to our tables, we determine if a table is proportional by doing y divided by x. So here I will do 1.25 divided by 10. So let's go ahead and open up our calculator, and I'm going to do 1.25 divided by 10. Here we get 0.125. So the rest of our values here should come out to be 0.125. So now I'm going to divide by y value, which is 2.5, divided by my x value, which is 10. So 2.5 divided by 20, we get 0.125. Here we get the same thing, so that checks out. Next I have 3.75 divided by my x value of 30. So 3.75 divided by 30. And here our answer again is 0.125, so that checks out. Please make sure you check all the values on a table. Do not assume that just because the first one or two or three are correct, that the last one is going to be correct. You have to check all of them. So whenever we do 5 divided by 40, we get 0.125. So here, whenever we do y divided by x for all of these values, they come out to equal the same. So this is proportional. So looking at the next one, again, we determine proportionality of a table by doing y divided by x. So here we're going to do -3 divided by 9. So -3 divided by 9 in our calculators. So -3 divided by 9, we get -1/3. If I want to convert that to a decimal, I do menu 1. I'm going to press enter, and I get -0.3. So the rest of my values should, when I divide y by x, they should be -0.3. Well, my next one is y, which is -1 divided by 1. I can tell you right now, it's not going to equal -0.33, but just to show you, -1 divided by 1, I get -1. So this is telling me that this graph is non-proportional. I have two, they're not the same, they're different. So this is non-proportional. Okay, next, my last table, we have -1/2 divided by -2, because remember we're doing y divided by x. So I have -0.5, which is the equivalent to -1/2, divided by -2. So let's go ahead and put that in our calculators. -0.5 divided by -2. We get 0.25. So whenever we put the rest of these in our calculator, it should be 0.25 as well. Here I have 3 halves, which that is equivalent to 1.5. So 1.5 divided by 6. We get 0.25. So that is correct. Then we have 7.5. That is 3.5 divided by the x value of 14. So 3.5 divided by 14. And again, we get 0.25. So whenever we divide y by x, we get the same thing. So this is proportional. Okay, so lastly, we have our graphs. So when we scroll down to graphs, remember, in order for a graph to be proportional, it has to go through the origin. And the origin is here at 0, 0. And it also has to be a straight line. This graph here is a straight line, and it does go through the origin at 0, 0. So this is proportional. Number 35, here I can tell you it does not go through the origin. It is a straight line, but since it does not go through the origin, that means that this is non-proportional. So again, that was 29 through 35, proportional or non-proportional.